record sent railwaymen the world over back to their drawing boards and set them thinking of a new future for railways. A future which could help solve the transport problems which the expansion of industry would surely bring. The difficulty facing the engineers was how to increase speed and track capacity without surrendering the many virtues of railways. No other means of surface transport can increase its capacity with so modest a use of land or so economic use of our dwindling energy supplies, and at such a low cost comparatively. The problem was to get the balance right, the balance between speed and fuel consumption, track capacity and preservation of land, between investment and technical advance. So the engineers came to the conclusion that what they were seeking would only be achieved by railway systems which embraced all their new knowledge. Knowledge of track design, of dynamics and adhesion, of stress, of power supply and propulsion, of air flows, of stability, braking and control. There is also a little matter of money. The engineers had to remember that a high-speed train must make commercial sense. It is not enough to show off, to break records. It is no good a train going faster if no one can afford the freight rates or to go for a ride. For the new trains were to be for everyone, not just the wealthy and the privileged. So the development and operating costs the trains incur, as well as the extra revenue they generate, must be honestly assessed and balance in favor of profit, not loss. On the plus side, these trains can be used more intensively. But the faster the speed, the greater the wear and tear on track and train, the more expensive the maintenance, the sooner the need for capital replacement. A high-speed train is not just a vehicle. It is a system of transport. And each country has to choose the system that best fits its geography, its economy, its resources, and above all, its transport needs. This is how Japan and Britain, Germany, France, Poland and Italy found their way into the new railway age. Japan is a country of islands, most of which are mountainous. The industrial cities lie along the Pacific coast in a long corridor between Tokyo and Osaka, called the Tokaido. Japan used to be served by a network of narrow-gauge railway lines which twisted and turned through the beautiful but difficult countryside. Soon after the war, the government realized that if industry was to expand and prosper, new standard gauge railways would have to be built. In 1964, the 500-kilometer Shinkansen line was opened. Since it opened, the system has carried 1,200 million passengers at speeds of 200 kilometers per hour. It has saved passengers 25 million hours of traveling, compared with the timings of the old narrow gauge system. Operation of the line is automated, and drivers are directly in contact with central control all the time. The new line has twice been extended, first to Okayama and then through Hiroshima to Hakata. The Japanese were quick to learn the benefits of new railways. They use little of their precious land, yet make the best use of dwindling supplies of energy. And now, 2 more lines are being built, part of a national plan to provide a high-speed network to cover the whole of Japan. Britain got carried away in the first great railway age and finished up with too many railways. Not for her the option of building new track. Instead, she had to cut back on what she had and think about going faster on what she kept. But going faster simply by increasing power was only part of the answer. Half of Britain's main lines are made up of curves, and half of these are relatively sharp. To straighten them would be ruinously expensive. The other part of the answer was to learn to go faster round the curves. Knowing full well that finer services and faster trains attract new, regular passengers, British Rail designed two trains. The first kind are already in service and have increased profits by providing the fastest, regular diesel services in the world. The second train is aptly called the advanced passenger train, for indeed it is just that. To keep passengers comfortable when taking curves very fast, the train was made to tilt. And the engineers built a train to prove it would work. To prove later stages of development, a complete experimental train was built. In spite of high speeds, braking distances could not be lengthened, for the cost of re-signalling was too high. The APT would have to have a new brake, so they invented the hydrokinetic brake. It is a water brake, or turbine in reverse, which generates braking power instead of a driving force. By the time it reached the production stage, APT had many new features. The body shells are made of aluminium alloy, 40% lighter than a standard steel coach. The aluminium extrusions run the length of the vehicle, and the seams are welded together. Articulation, the sharing of bogies between coaches, reduces wear and tear, drag, energy consumption, and therefore cost. This, then, is the British entry into the new railway age. They call it by its initials, the APT, and it truly is the most advanced passenger train. Poland's greatest need to get into the new railway age was a new line to link Silesia with Warsaw and the Baltic ports. The old line could no longer cope with the expanding traffic, and congestion threatened to curb the country's economic expansion. So urgent was this line that the first section from Silesia to the north was opened as a single track, and trains ran on it while the second track was being built. The new track is a high-speed freight line. It also carries passenger trains at 200 kilometers per hour, but freight is the first priority, and the new line is designed to carry 5,000-ton trains at high speeds. Built in 4 stages between 1971 and 1983, the line is not intended to serve the countryside through which it passes. It passes by rather than calls in. Its purpose, to reach its destination by serving the needs of railway operators. No fewer than 15 variations of the possible route were investigated. Great care was taken to avoid areas of natural beauty and recreation. New surveying methods were employed to gather the most detailed geological and geographical information. Great care was taken, too, to minimize the disturbance to the people through whose homeland the line travels. Discussions were held with the local people in places where their traditional way of life might possibly be disturbed. Already, Poland's railways carry more than 400,000 tons of coal each day, and each day capacity increases. By 1982-3, the new line will be open all the way to the Baltic coast, so opening up a two-way traffic in and out of the ports. And Poland will have entered the new railway age with a new economic lifeline. The war left Germany divided, and the division cut through many of its main railway lines. For the chief flows of passengers and freight had always been east-west. Since then, the rail traffic has had to find other ways to cross the country. But the old north-south lines could not properly accommodate all the extra traffic. Clearly, new lines would have to be built. A cost-benefit exercise related to the whole economy was mounted to decide where the new north-south lines should be and in what order they should be built. Of the 6 new lines shown to be necessary, the Mannheim-Stuttgart line was expected to show the highest benefit and to compete most successfully with canals, pipelines and roads. But there was a problem. High-speed passenger trains and frequent freight trains do not fit happily into the same timetable. Was it better to go faster or carry more freight? German people like to travel as fast as anyone, and to prove it, their present engines can reach 200 kilometers per hour with ease. However, extra freight trains were necessary too, and so very high speeds had to be sacrificed to make room for them. Nonetheless, with an eye to the future, the Ministry of Transport built a test laboratory to study the interaction of steel wheels with steel rails at very high speeds, up to 500 kilometers per hour. This is a model of the test rig. Outside the laboratories, construction continues on the line between Hanover and Würzburg. As part of a determined effort to protect the environment, the Railway Construction Center produced noise maps for the Mannheim route so that noise sources could be identified and action taken to baffle them in advance. Once the new lines are built and the existing ones upgraded, the Deutsche Bundesbahn will be carrying passengers and freight with the speed, frequency and punctuality well suited to a new age for the railways. In the early 1960s, so many trains were travelling on the lines between Saint-Florentin and Dijon that at peak periods, both lines of the double track had to be used in a single direction, turn and turn about, to enable the fast trains to overtake the slower ones. Clearly, there was no room for the increase in traffic which was expected. Neither was there room to lay more tracks alongside the old. The only profitable answer was to build a new line from Paris to Lyon with a branch to Dijon. The new line would save 90 kilometers in all and provide a fast rail service for some towns previously ill-served. And if France were to have a new track, why not a new train too? Indeed, the train came first. The prototype was turbo-driven, but the continuous research for savings in fuel consumption proved that electric power would be more economical. Meanwhile, the new line progressed. After the initial feasibility study, an increasingly detailed investigation was made into its route, and the exact line of the new track was determined in collaboration with landowners and local authorities. Construction began in 1976. In spite of the magnitude of the work, great care was taken to protect the environment, for the plans had to withstand the scrutiny not only of the Ministry of the Quality of Life, but also of Culture and Agriculture. The new trains are full of technical innovation already tested and approved in the prototype. They have permanently coupled carriages, each sharing a bogie with its neighbour, and an engine or power car at each end. They are capable of running at 260 kilometers per hour. But these are not luxury trains for expense account travelers. 2/3 of the seats are for those of more modest means. The new line will open in the autumn of 1981. It will be kind to the French environment, good for the French economy, an example of efficient use of land, energy and capital. Indeed, a magnificent step forward into the new railway age. The railway from Florence to Rome, from the Arno to the Tiber, is a beautiful line. But it is also one of the busiest railway lines in Europe, for it carries 1/3 of all the rail traffic in Italy, and yet it is little more than a mountain railway. It was put together in the last century simply by joining up the local lines built by the small sovereign states. Consequently, it is 35% longer than a straight line drawn between the two ancient cities. With ever-increasing traffic and public pressure for shorter travel times, Italy decided that a new line was essential and that it would have to go straight. In 1970, building began. The new line cuts straight through mountain and over ravine, but at 8 places it connects with the old line as it weaves back and forth, clinging to the contours of the countryside. By allowing trains of different speeds, purposes and destinations to switch from old line to new and back again, these interconnections have the effect of doubling the track capacity, the earning power of the railway. The Italians are passionate civil engineers, and the engineering of the tunnels and viaducts of the Direttissima are among their finest work. The 17 tunnels total about 40 kilometers. The bridges and viaducts, almost 19 kilometers. The most majestic is the viaduct over the valley of the River Paglia. Over 5 kilometers long, it is one of the longest railway viaducts in the world. As the new tracks are laid, they seem to form a pathway to the new railway age. And the portals which carry the power lines become triumphal arches for the new railway, monuments to the fruits of technology rather than to the spoils of war. Today, the railways carry all kinds of passenger with equal speed and comfort, for the new trains are for everyone. The end of a journey, the end of this film, but not the end of the story. For now, in spite of the growing shortage of space, of capital, and of energy, we can see how well the railways are suited to satisfy the future transport needs of the world. Yet another railway age is on its way.